Hey everyone! So in this video, we're actually starting something new. Although it doesn't sound new, we're going to be doing transformations with absolute value. This is not the absolute value function, this is its own transformation. So there are two different ways. There's using it for your x values or your y values. So let's first start with what it looks like for your x values. So that's g of x equals f of the absolute value of x. Okay, so I'm saying this function is going to be some original function where we take the absolute value of the x values because it's inside with the x's. So this means any values on the right half of the graph stay on the same side. And are reflected over the y-axis. Okay, so let's do an example. So if I want to graph f of x equals 2 times x minus 1 squared plus 1. So that's my original f of x. And then what we want to graph is g of x. And that's going to equal f of the absolute value of x. Okay, so this is our ultimate goal. This is what we actually want to graph. And I'm going to show you the steps on getting towards this final answer. So first of all, you want to focus first on, let's do it in a bright color. You want to focus first on this function. And like, what does that graph look like? So I would list the transformations first. So we have a vertical dilation by 2. And then we're going right 1 and up 1. So we're translating okay. For graphing that, if you like the table method, which I think is really great because it helps you get some partial credit. For quadratic, remember we have -2, -1, 0, 1, and 2 are the key points. And if I substitute that into the parent, we get 4, 1, 0, 1, and 4. So for this new function, a vertical dilation by 2 will be 2y. Going right 1 will be x plus 1, and up 1 will be y plus 1. So -2 plus 1, -1 plus 1, 0 plus 1, 1 plus 1, and 2 plus 1. Then we have 4 times 2 plus 1, 2 times 1 plus 1, 0 times 2 plus 1, 1 times 2 plus 1, and 4 times 2 plus 1. Okay, so this is just this original f of x function. So now I'm going to graph that on a coordinate plane. I'm going to do a scale of 2 just to make things easier. 10, 8, 6, 4, 2. And then my x values, I'll just do a scale of 1. Okay. So my original function is at negative 1, 9, 0, 3, 1, 1, 2, 3, careful of your scale, and then 3, 9. And this is a parabola. Okay, so how do I graph what I want? So this isn't even like our answer. Remember, so this is the absolute value of the x values. So the absolute value of 3 is 3, so we still have the 0.39. We still have the 0.23, 1, 1, and 0, 3. So all of that is still a part of the new function. But now we also are going to have negative 1, negative 1, 1. And this is going to be 2, so now it's going to be negative 2, 3. And then 3, 9. Negative 3, 9. So this whole thing that I've just gone over in blue is our g of x function. Okay, so negative 1, when we take the absolute value of that, it's 1. And so now at, like, what would the corresponding y value be? So at 1, it's 1. So basically, now all of your x values have to mirror what the original x values were. Okay, so that's for the x's. Now let's do the y's. I guess I could do a different color. So if we want g of x equals the absolute value of f of x. So now that's the absolute value of our y's. So now any values above the axis stay the same. And any values below the axis are reflected over it. Because we're making them positive, right? So we made all these x values to correspond to their positive x values. Now we'll do something similar here. So, example, if the original was, let's do something similar. Let's do f of x equals, we'll just do another quadratic because those are nice for, it's a nice visual. And let's have our g of x function equal the absolute value of f of x. And this time I'll do it in green. So this is going to be my final answer. So again, I would start by graphing this, and this is being translated left 1, down 2. And then do some dilations, so I feel like this one's a little bit easier. I'm not going to make a table. So my graph, I'm going to go up to 4, I guess. So 4x4 coordinate plane. Right. So the original function, left 1, down 2, and then be 1, 1, and then at 2, 1, 2, 3, 4. Okay. So here's my original parent. Well, not parent, sorry, f of x. So, in this case, everything, like when the y values are positive, that's where it stays as is. So this is a part of our g of x function. But then we're taking the absolute value of the y's. So everything down here now has to be positive, right? So the absolute value of -1 is +1. So here we're going to plot at +1. Here we've got -2, so we need to plot that at +2. Here we have -1, so at 0 we're now at +1. Now here's the interesting thing. What happens at the 0, it's now going to bounce off the axis. So we're going to come down and it's going to curve up. And then it's going to bounce again off the axis. So what I've highlighted in green is our new g of x function. Okay, so quick recap for absolute value of the y's. So you have your original values, and then anything that was negative, you take the absolute value of it. So that's why we now plot it above. It's reflected. And this whole thing is the new function. Recapping here, similar idea, except we take the absolute value of our x value. So here at -1, like we have to graph the equivalent of +1, so that's why it's 1, 1. And then here, we don't plot the original, we have to take the absolute value, so now it's going to be whatever the same y value is for +2. So the x values are still negative, but it's not the actual function's y values, it's what is the positive versions. So this one's a little bit harder, but with practice, it'll get easier.